right, so let's talk about division now. Division, of course, is the flip side of multiplication. It's the undoing of it. So there's two types of division. It's when there's an unknown number of groups. You don't know how many groups we have. That's called measurement division, which is not really that important to remember. It's just realize that sometimes the groups are unknown, the number of groups. And then, of course, sometimes the group size is unknown, how many's in each group. And that's called partitive division. So let's look at how we record this. When we record something, the number of groups, that's the first factor. And then the size of the group is your second factor. And the total is your product. And we need to use this language with our kids. We need to talk about how a factor times a factor is a product. But we also have to say groups of, like 3 groups of 5 that we did just earlier equals 15. Okay? So just, you have to work with the kids and have them use that language in there. Read this multiplication sign as groups of, and read this equal sign as is. Okay, let's look at this one. We think about division as a multiplication problem that has a missing factor, just like we think about subtraction as an addition problem that has a missing add-in. So we ask ourselves, 6 groups of what is equal to 48? Or 8 groups of what is equal to 48? I was giving the answer, wasn't I? Okay, so how could the kids figure that out? What could they do? If they didn't know that fact, what could they do to figure it out?
Could they put items in the bag until it reaches 48?
Absolutely, they could. They could do a fair share. They could do a fair share until they get all 48 in the bags equally. So they could count out 48 and do a fair share and then see how many's in a bag, each bag once they're finished. So what's missing here? What's unknown? Is it the number of groups or is it the size of the groups?
Size of the group.
The size of the group.
Size of the groups. So 16 action figures are arranged equally on 2 shelves. So how many action figures are on each shelf? What's missing there? Do we know the number of groups?
Yes.
Yes, 2, right?
Number of groups missing.
Yes. Do we know the product? Do we know the end result, how many there are altogether?
Yes.
Yes. So what do we have to do again? We're going to have to do that fair share again. So I can see where the kids could make 2 groups, and then they could fair share until they get to 16. They could take 16 objects and fair share into 2 groups. And if they need to work it out and figure it out that way. So this is what this is looking like. 2 groups of what is equal to 16. That's why I always tell my kids, whenever they talk about, we want to learn how to divide, we don't know, we want to learn division facts. And I say, well, you're learning them. When you're learning your multiplication facts, you're learning your division facts. Because all we do is just undo them, take them apart. Your favorite marbles come in bags of 10. If you want to purchase 60 marbles, how many bags will you need to buy? What's missing here?
The number of groups.
The number of groups. We know what's in each group, but we don't know how many groups we need. So here, we're looking at how many groups of 10 is 60. Well, that's what we're looking at here. This remind you all of something we talked about yesterday? What's this looking like? Remember how we talked about the missing add-ins is a link directly into algebra? Missing factors are also.
I could see how that would help them when they get ready for algebra.
Yes. Yes. All you do is plug in a letter. So N, what does N represent here in this problem? So what is N in this problem? What could I put in place of N? 6, right? So it directly links the kids into an understanding of algebra. Okay. Division terms and notation, if we're going to do this with division, says, well, this is just showing that same thing again. 8 groups of 48, but it's showing you how you could write it as a division problem, is what they're showing. So it's the same type of problem. So 48 divided into 8 groups, and we said that left us with 6 in each group. This is 60 marbles divided into groups of 10, leaves us with 6 groups. So of course we teach that terminology: dividend, divisor, and of course the answer when we're dividing is the quotient. So it's important that the kids learn this terminology as well. Okay, let's look at this for just a moment. So if we had this illustration to look at, this situation. So if we said 12 divided by 3 is 4, what's the 12 representing?
That's the quotient, or all the total.
Right, that's the 12 fish, right? And they're divided by 3. What's the 3 represent?
That would be wrong because that is not the number of groups, right?
That'd be how many fish were in each group.
That's how many fish are in each group, yes. So yeah, it depends on, with division, it's a little different. We can look at the scenario and think about what the numbers stand for. So 12 fish divided into groups of 3 leaves us with 4 groups.
Okay.
Okay. Now let's look at the other one. We can look at it differently as well with this one. 12 fish divided into groups of 4 is 3 fish in each group. So you see how it's differently, it works a little differently with the division. It's when we're modeling that multiplication, so we have to be careful about factors and how we read them. But with division, it depends on how we look at it, what's missing. We can do either or with that. Let's talk about that dreaded 0. Kids have a time with understanding 0 if you don't model it for them. We have to model it. 4 groups of what will give us 0?
0.
0. There's nothing else that can go in there. If you have nothing, you have nothing. So you have to model that for the kids because they have a hard time with it. One
And you
reason
can't have 0 groups.
Right, and you can't have 0 groups. But here we're talking about 4 groups. But right, we couldn't flip-flop it either. But you have to model it for them. And the reason the kids have trouble with that sometimes is because they've just learned their addition facts. And sometimes they'll confuse the addition facts and want to put that would equal, that 4 times 0 would equal 4. You'll see that sometimes out of your kids too. They'll confuse the two. So let's look at this scenario. Gina and Tim are arguing about which value makes the equation blank times 0 equals 0 true. They're arguing about what could go in that, what could be that first factor. Well, Gina says that 9 will make it true. And Tim says that 1 will make it true. So Gina is saying that 9 times 0 is 0. Tim is saying that 1 times 0 is 0. So who's correct? Gina, Tim, both, or neither? So which one's correct here?
Both of them.
Both of them. Yeah. And the kids have to, they have to experience that. They have to look at it. They have to draw them out sometimes to understand that with 0, it can be more than one. There can be more than one factor that can go in that to make that true. And then you talk about the endless possibilities. They love the fact that once they discover that, they'll give you wild numbers, outlandish numbers that could go in there. 100 times 0, 1,000,000 times 0, 1,000,000,000,000 times 0. They love to throw out those numbers once they understand the concept. So we have to let them work with those smaller numbers and get them to draw 9 groups. If you put nothing in 9 groups, what have you got? Nothing.
No, I still just think it all goes back to modeling and making sure they have that concrete understanding of what those numbers represent, and being able to show them several different ways so they can activate prior knowledge as well as make a connection.
Yes, you're absolutely right. You are right. We have to model. We have to model. Like if I wanted to model 4 groups of 0, then I would put out 4 groups and I'd put nothing in them. And I'd ask, okay, what have you got? Nothing. There's nothing in there. There's no cubes in there. Nothing's in there. And then we could model 5 times 0. And then we could model, and you're right. But you are exactly right. We've got to do that. And then we've got to take it that next step. We've got to do the concrete. And then we've got to model that semi-concrete where we draw our 4 groups and we put nothing in them. And then we take it on to that next step. 4 groups of 0 is 0. Modeling all the way. Okay. So why not division by 0? So if you take 15 counters, how many sets of 0 can be made? Does that even make sense? That's why we can't divide by 0. Put 12 blocks in 0 groups. That's what Stephanie was saying earlier. We can't have 0 groups either. And put them in and put 12 blocks into them. And can you show me how to share 5 oranges with 0 children? Well, if you have no children, you can't share them. So that just the situations don't make sense, which all comes back to we have to put a story with it for it to make sense. If we put stories with their equations, it helps for the kids to see it and visualize it, and it makes more sense to them.